It's one small step for man, one giant leap for mankind.
On that unforgettable day, July 20th, 1969, Neil Armstrong became the first human to set foot on another world. Apollo 11 was the first of 6 crewed missions that landed on the moon. Neil Armstrong, the first of 12 men to leave footprints in the lunar dust. But the Apollo lunar program ended in 1972, and we haven't been back since. But now NASA is taking some small steps to return to the moon. And they're getting ready for another giant leap. It's the Lunar Reconnaissance Orbiter, and it's next on Real World. When astronauts first went to the moon, they never stayed for more than a few days at a time. But plans are underway to go back for what NASA calls a sustainable, long-term presence. This time, we're going to stay. But how do we get there? What supplies should we bring? Where should we build our outposts? This mission is going to require lots of planning. And that's where the Lunar Reconnaissance Orbiter, or LRO, comes in.
The Lunar Reconnaissance Orbiter has a suite of instruments which will measure various components, various aspects of the lunar surface in high definition in a detail that's never been measured before.
Noah Petro is a postdoctoral researcher at NASA's Goddard Space Flight Center in Maryland.
We're going to see the moon in a completely different way, essentially creating an atlas of the moon that will be used by scientists and by NASA to determine what's at the surface of the moon, the spatial extent, where things might be found, also to be used to find safe landing sites for future exploration, and to give scientists an idea of how the moon has changed and evolved over the last 4.5 billion years.
The Lunar Reconnaissance Orbiter was built at Goddard. It's the size of a large SUV and will carry 6 scientific instruments. Orbiting 50 kilometers above the moon in what is called a polar orbit. It will pass over both poles every time around. As the moon rotates, the spacecraft will eventually cover the entire surface of the moon several times.
The Lunar Reconnaissance Orbiter, one of its missions is to look for safe landing sites in those areas around the poles and look for resources in those areas around the pole.
John Keller is the Deputy Project Scientist for LRO.
We have 6 instruments on the spacecraft, very high resolution cameras, the laser, which gives us measurements of the distance from the spacecraft to the surface by what's called laser altimetry. Laser bounces light off the surface of the moon and measures the amount of time for the round trip from reflected light to get back.
Scientists will use data from this laser altimeter, called LOLA, to create a high-resolution topographical map of the moon's surface.
We have a radiometer, which will measure the day and nighttime temperatures of the surface. We also have on the spacecraft a UV spectrometer, which will measure essentially reflected starlight on the night side of the moon, and also give us the ability to peer into the craters at the poles, which are permanently shadowed because of the low angle of the sun.
Additionally, LRO has a cosmic ray telescope instrument to measure the radiation environment of the moon, including a brand new innovation, something called tissue equivalent plastic, which mimics human tissue.
We're going to measure how cosmic radiation and solar energetic particles are deposit their energy into this plastic. It will be used by the medical community to understand the interaction of radiation with biological tissue.
The 6th instrument on LRO is the Lunar Exploration Neutron Detector, or LEND, which will create a high-resolution map of hydrogen distribution and gather info about the neutron component of lunar radiation. Scientists will study its data, looking for evidence of water ice near the moon's surface. That's a lot of responsibility for one lunar orbiter. Just to make sure LRO can handle all that, it's going through some rigorous testing in the days leading up to its launch.
This is the thermal vac system. So the spacecraft's in this, and this is a very large vacuum chamber. We use it to not only simulate the vacuum conditions of space, but also the thermal conditions.
Because there is no atmosphere, the surface temperatures will range from 120 degrees centigrade down to -170. and the spacecraft sees those thermal changes.
We have heaters in there. We were heating the spacecraft up fairly rapidly and then cooling it down with baffles of liquid nitrogen in order to simulate that fairly rapid transition that occurs when the spacecraft goes from the night side to the day side. You know, the spacecraft orbits the moon in under 2 hours. And so it sees those thermal transitions pretty rapidly.
But once it's up, it's going to return an unprecedented amount of data.
The data is dominated in terms of quantity by a set of high-resolution cameras called the narrow-angle cameras. These cameras will give us resolution on the surface of the moon from a 50-kilometer orbit, half a meter. So a pixel size is going to be about a half a meter. But it will take strips, the two cameras together can take strips of images which are 5 kilometers wide and 25 kilometers in length. How many pixels is that? Well, it's 5,000 times 25,000 times 4, which comes from having a half meter resolution. That tells you how many pixels each individual image will be. Now we can take up to 12 images per orbit, and we get a little over 12 orbits per day. And the first phase of the mission is a full year.
Wow, that's a lot of digits. So the Lunar Reconnaissance Orbiter is the first step in our return to the moon. And returning humans to the moon will help scientists, and all of us, in fact, address fundamental questions about the history of Earth, the solar system, and the universe, and about our place among them. And in the words of Neil Armstrong, that's a giant leap for mankind. Keep track of the LRO mission at www.nasa.gov.